Hello, in this video we are going to implement some machine learning classification model and we will predict some target value for the given dataset. So this is our dataset for training purpose. Here approx 18 features are given and here is a target value. So we will train our model on this dataset, and this is another dataset for testing purpose, and we have to predict the target value for this given dataset. So let's start. So first we will install scikit-learn library, which is a Python machine learning library. Now we will import pandas library to work with data frame. Now we will import our training and test data set here. So for this, using pandas library. Okay, we can visualize our data frame. We will store from column T1 to T18 as xtrain, because this is for training purpose. And target value as ytrain. Okay. Now for testing, we will import another dataset. We will store as xtest. Okay, now we will use the standard scaler method, which is a feature scaling method, which will remove the mean and scale all the features to unit variance. So basically it helps to reduce redundancy and inconsistency present in the dataset. Brackets. Okay, we apply here for xtrain data. Now we'll do it for xtest also. Okay. Now we will implement machine learning classification models. So first we will implement logistic regression. So logistic regression is an important classification algorithm which lie in the category of the probabilistic family of algorithm, and it basically try to fit a relationship between the set of independent variable and dependent variable. So for this linear model, import okay. We'll train this model on xtrain and ytrain. Okay, warning. Okay, basically LBFGS is the default solver for this scikit-learn library in logistic regression, and here it's a suggestion to try to make the solver to converge. So we will increase our iteration for this. By default it is 100, but we will make it 1000. Okay, just taking more time. Okay, done. Okay, now we will predict for X test. Okay, so this are our target values. Okay, we can store this and by. Okay. Now we will also find the training score here. Okay, 0.977. Okay. Now we will store this target value in df1, which is on our data set for testing. Target. Okay, now our data frame will look like this. Okay, this is the required target value which we have found using logistic regression model. Okay, now we will apply the next algorithm, which will be NaiveBayes. So this is another algorithm which lie in the family of probabilistic family of algorithm, and it based on the Bayes theorem and work on the assumption that all the predictors of features are independent of each other, and it uses Gaussian distribution to calculate the likelihood of features. So for that, from scikit-learn, okay, we will train. Okay, now we will predict the required value. We will store it in Python. Okay, I will also find the training score. Okay, and also store this value in df1. Okay, so our data frame now will look like this. Okay, the value are same predicted by this both algorithm. Yeah, but the score is less in Gaussian than logistic. Okay. Okay, now we will implement our next algorithm, which is KNN, which is K nearest neighbor. It is the algorithm which lie in the deterministic algorithm, and it basically classify new data points depending upon the majority of the class of the data points among the k neighbors, where k is the number of neighbors to be considered. So this algorithm uses Euclidean distance for this to converge to a solution. So for this we will use from scikit-learn dot neighbors import. Okay, first we will set the value of k will be like 3. It will be better to take the odd value to be the value of k. Okay, spelling mistake. Okay. If we now predict the score, find the score, training score. This double line to 1990. Okay, we increase this value of k. Yeah, so it is decreasing. So if we decrease the value of k like 1, oh, it's increased. So we will set the value of k should be 1. Now we will predict for X test using this model. And we'll store it in this variable. Okay, and we'll again store in our TF1 data frame. Okay, cool. Okay, so now we will use another classification model which will be SVM, support vector machine. So this model is also a deterministic based algorithm, and this work for both classification and regression, and can also classify or work for binary or n-ary classification using OVO and OVE trick. Okay, now we are training our SVM model. Sorry, just as see. Okay, if we predict using this model, and we can also find the training score. So we predict is running. It is taking much time. Okay, 0.99012. Okay, less than KNN. So KNN score is the highest among all these. Okay. Now we will save this prediction DF1. Okay, this is our data frame. Okay, now we will implement our next machine learning classification model, which will be DecisionTree. So it is our simplest classification algorithm which work like our human thinking. We can visualize as a tree where node act as an attribute and branch of the tree will be act as a rule or decision making, and the leaf node will represent as an outcome which can be categorical or continuous. So we will implement this algorithm. So for this, from scikit-learn import tree, then DecisionTree classifier object. Okay, now we will train this model on X-train, Y-train. This is a classifier. Oh, sorry. The tree should be there. Okay. So now we will predict for X test. and we'll also find the training score for it. Okay, 0.9994280. Yeah, it is similar to KNN 42860-50326. Yeah, it is same to KNN. So among all these models, KNN and the DecisionTree gave us the highest training score. Okay, now we will store this prediction also in our dataset. YTT. Sorry, we will store as a target decision tree. Okay, now this is our data frame. So we have predicted the required target value using logistic regression, Gaussian, KNN SVM, and DecisionTree. So using 5 machine learning classification model, and the predicted value looking same, but the KNN and DecisionTree gave us the highest training score here. So this is was our project. Okay.